Oh, can everyone hear me? Okay, thank you. Just a quick question for the lecture today. Did professor just go over permutation or also combination? Anyone attended the lecture today? Just permutation? Okay, then I think I will exclude the combination from the tutorial today, which means that I think you should think about one question like from any chapter that you want me to go over, because we might have extra time. I will cross out this question for the tutorial today because it relates to combination as well. And then also, let's see. 3 is fine. I will also cross out question 4 for the tutorial today. We will go over it in the next tutorial. But since you didn't study combination yet, so I will cross out question 4 and question 1b. So we might have extra time. So you should think about which question in the textbook that you want me to go over in the end. If you don't have any question in the textbook that you want me to go over, we might be able to finish the tutorial today early. For everyone who just joined, I was talking about that I will exclude combination from the tutorial today because you didn't go over that in the lecture, which means I will cross out question 1b and question 4. So you should think about whether there are any textbook questions that you want me to go over to compensate for that. It can be from any chapter from 1.1 to 2.3 because your midterm will cover up to 2.3. Yes, do you have any question in mind, like specific question? Like pick something that you feel like you attempted, but you struggle with it. Problem 3 from section 2.2. Okay, I will note it down. If we have time in the end, we can go over problem 3, section 2.2. Okay. Otherwise, I will start the tutorial today. We will just talk about permutation. Let's say you have n distinct elements. And the distinct part is very important. You want to arrange k elements out of n. Then the number of ways that you can do that is n minus k. Not this one, sorry. It would be like n times n minus 1 times n minus 2 up until n minus k plus 1. Because if you think about it, you have k position in total. Like this is the first position, the second position, the k position. And for the first position, you'll have n choices to choose to fill in. And in the second position, since one of the item is already being filled in the first position, so in the second position, you only have n minus 1 choice left. And similarly for this one, you only have n minus 2 choices left. And this is just equal to n factorial divided by n minus k factorial. Does this make sense? Okay. Next one is, the thing is why the distinct is important, because if you think about that, let's say you have 3 objects, V1, V2, and V3, then the number of ways that you can arrange these is 3 times 2 times 1, which is 6, right? However, if you have something like V, and V1, you cannot do 3 times 2 times 1 equal to 6 ways to arrange these 3 objects, because that is incorrect. If you actually try to arrange these 3 objects, you will see that there are only 3 possible options like this. So why is it different, like between this one and this one? Because for this one, whether this V first or this V go first, it doesn't matter. It will give you the same thing. If this V go first and this V go after, you still have V and V. Or this V go first and this V go after, you still have V and V. Which means you would have to take the number of ways that you arrange 3 distinct elements. You divide it by the number of ways that you can actually arrange these 2 V as if they are distinct objects. So you have to divide by 2 factorial for this one. And it will give you 3 ways, which is the correct answer. I believe it is called permutation of multiset. Let's say you have a set S contain n elements. And in set S, you have k types of object. Let's say type 1, you have n1 object. Type 2, you have n2 object. Up to type k, you have nk object. And if you add n1 plus n2 plus n3 up until nk, you should get n objects in total, which is the number of elements in S. Then the number of ways to arrange elements in X is n factorial divided by n1 factorial, n2 factorial, up until nk factorial, like this. So the most popular problem that you might see for this kind of permutation is, let's say you have let's say you have 6 balls. Out of that, you have 3 red, 2 blue, and 1 green. And they will ask you the number of ways to arrange 6 balls. Then in this case, n is the total number of balls that you have, which is 6. So I will use this formula. I have 6 factorial divided by red is one type, blue is one type, green is one type. So the number of balls in type 1 is 3. So I divided by 3 factorial. The number of balls in type blue is 2. So I divided by 2 factorial. And the last one is 1 factorial. So this is a formula for permutation of multiset. Does this part make sense? Please let me know if you're confused about any part. And if you think about this formula, the formula here, isn't that formula for when they aren't distinct? Yeah, this is for when they aren't distinct. For example, like the 3 red balls, they are not distinguishable, right? And the 2 blue balls, they are also not distinguishable. That's why I put them in one type. Why aren't they distinct? Okay, if you pick the red ball and the blue ball, then they are distinct, right? But if you take 2 red balls, then they look the same. Yes, that's correct. So you can think of it as like you have 3 red, you have 2 blue, and 1 green, like this. And if you relate this to the case where everything is distinct, like if you relate it to the case where you have n distinct object, and you want to arrange those n distinct objects, then the number of ways to arrange the n distinct object is n factorial divided by 1 factorial, 1 factorial. Everything in the denominator is 1 factorial because n objects are distinct. So each object, they belong to their own type, which means each type only have 1 object. And then eventually this is n factorial, which is some formula that you already know. I don't recommend you to memorize the formula, but it's really up to you. Rather, I think counting problem, you should focus on how do you actually arrange the object to achieve what you want. And then in each step, how many ways you can perform that step. Any other question regarding to this? Next time when we talk about combination, I will also start with this one. I will also start with permutation of multiset to transit to combination. Because in the end, if you try to think of how every formula relate to each other, it will make total sense. If there is no question, I will leave you time to think about question 1. Maybe 5 minutes. You can type in the chat or speak if you have any question. Anyone got the answer for part 1? How will you distribute 10 distinct gifts among 3 friends? You mean this one? 10 minus 3 factorial. Why is that? The thing is, we want to distribute all the gifts. This number here, what it means is like 10 times 9 times 8, right? Which means like you have 3 friends, friend 1, friend 2, and friend 3. And then you give each of them one gift. Then there is a number of ways to distribute the gift if each of them receive exactly one gift. But we want to distribute all 10 distinct gifts. For example, like you can give friend 1 8 gifts, like give 1 from give 8, and you give friend 2 give 9, and give friend 3 give 10. So that is one possible way to distribute. If we count all possible ways to distribute, then how many would we get? Another way you could think about this problem, instead of like having friend 1, friend 2, and friend 3, and you are trying to distribute the gift to each friend, if you do like that, you will have to do lots of cases, because it depends on how many gifts that each friend's gonna take. But if you look at the problem in different way, like if I write down, give 1, give 2, give 3, up until give 10. I can assign the label to each gift. For example, if I assign the label friend 1 to the gift 1, then it means that I will give friend 1 this gift. And if I label F2 to G2, it means that I will give friend 2 this gift. So the problem comes to how many choices you can assign to give 1, how many choices you can assign for give 2, how many choices you can assign for give 3, and up until give 10. So what will you get if you think of it that way? If all the gifts are identical, isn't the only way they are distinct is if one friend gets one more? The original question is we have 10 distinct gifts. The gifts itself are not identical. That's why, like, if you give gift 1 to friend 1, and you give gift 2 to friend 2, it is different from you give gift 2 to friend 1, and you give gift 1 to friend 2. They are different because the gifts are distinct. If the gifts are identical, then these two ways of distribute are just the same. So for part one, it is when the gifts are distinct. I see some students give this answer. How did you get it? How do you achieve this answer? I will let you think about that. This is incorrect as well. Three to the power of 10. Yeah. Because if you think about this, for gift one, I have three choices, right? I can give gift one to friend one, or friend two, or friend three. So there are three possibilities that I can assign for gift one. Similarly, for gift two, I can give it to friend one, friend two, or friend three. So I also have three choices. Similarly, for every gift. So you would have 3 to the power of 10 ways to distribute the gift. If you think about the process of distributing the gift is, okay, step one, I distribute gift one. And I have 3 ways to distribute this. Step two, I distribute gift two. I have 3 ways to distribute it. Up until step 10, I distribute gift 10. I also have 3 ways to do it. Since they are sequential steps, for each way in step one, we have 3 ways to do step two. For each way to do step two, we have 3 ways to do step three. So you can use multiplicative law. So you have 3 times 3 times 3, 10 times, which give you 3 to the power of 10. Let me know if this makes sense or you have any question. When the gifts are identical, it is a more difficult problem. We will get to that in next week. Any question about part one? Okay, if not, then let's move to part three. We want to distribute 10 gifts, but we want to make sure that each friend should receive at least 3 gifts and the gifts are identical. So when the gifts are identical for this one, it makes our problem a bit easier because you don't need to care like, okay, friend one is getting gift one, gift two, gift three, or like getting gift one, gift four, gift five, something like that. Then you will have to account for the label of the gift. But here, all the gifts are the same. So you can think of all the gift is just the single letter G. So you cannot distinguish between any two gifts. You want to distribute it such that each friend have at least 3 gifts, right? So in real life, how would you do that to make sure that the condition is satisfied? How would you distribute for friend one, friend two, and friend three? to make sure that each of them will receive at least 3. You give each of them 3. Yeah, that's correct. To make sure that at least 3 for like each friend receive at least 3, then we just give each of them 3, right? So I distribute 3 for each of them. And how many gifts do I have left after I do that? I only have 1 gift left, right? And how many ways I can distribute that 1 gift left? 3, right? So that 1 gift left, I can put it here, or I can put it here, or I can put it here, right? Which means there are 3 cases. The first case is when friend 1 get 4 gift and friend 2 get 3 gift, friend 3 get 3 gift. So this is the first case. The second case is when friend 1 get 3 gift, friend 2 get 4, and friend 3 get 3. The last one is friend 1 and friend 2 get 3, and friend 3 get 4, like this. So for this kind of problem, when they ask you to distribute something such that like each of the friends have at least some amount of gift, just first distribute that minimum amount to everyone. Then the number of ways you can distribute in total is the number of ways you can distribute the remaining gifts after you satisfy the minimum. Does this make sense? If you're dealing with larger number, there is a way to do this more systematically, but then we haven't got to that point yet. So we are only dealing with small number like 10 now. Yes, the answer for part 3 is 3. These are the 3 ways to distribute 10 identical gifts that satisfy the condition. Is there any other question regarding to question 1? To recap, the first part is just to shift your perspective. Instead of thinking what gift to assign to each friend, we can think of what friend that we will give the gift to for each gift. So that is what I want you to achieve, like having different perspective about the problem. And for part 3, it is to get you familiar with the kind of question that have the minimum number of objects in each group. Then you have to just give each group the minimum amount first and then try to deal with the remaining objects later. If there is no question, I will let you work on question 2. So here I have the vowels. O, A, I, and O. And then consonants, N, T, and R.
For part two, do they mean like all of those three are together? All the vowels?
No, they don't have to be together. They only need to be in alphabetical order.
All right.
Yeah, which means like something like this is acceptable. Anyone got the answer for part one? How do we make sure that no two vowels will be next to each other? We have 4 vowels here and 3 consonants. I got 3 factorial times 5 factorial. How do you get that though? Like for combinatorics problem and like for any question in general, it's more important about how you got to the answer than the final answer itself, you know, like is where you think incorrectly that leads to the incorrect answer. So it's more important to like fix that.
Oh, okay. Oh, should I just say what I did then?
Yep.
I put like the consonants first, right? So I have 3 of those. Like I wrote out the 3 consonants, like, and then each of those is 3. Since there's 3 consonants and there can be 3 arrangements of those, right?
For this one, like NT
Yeah.
and R, right?
Yeah, for NTR. And then I saw that in between those we have 4 options to put all the vowels, right?
NT and R, you mean like this?
Yeah.
Yes.
And there's 4 ways. There's 4 vowels and 4 ways. So we're just gonna have 4 choose 4, which I think is 4 factorial, right? Yeah.
4 factorial to arrange the O, A, I, and O.
Yeah.
Where is the 5 coming from?
Oh, I think I misclicked that. Oh my bad.
Oh, okay. Okay. It's pretty close. It's pretty close actually.
I was thinking that maybe since we have two O's, we divided by 2 factorial, but I wasn't too sure about that.
Yeah. You should because they are 2O, right? They are
Mhm.
like the same object. So you definitely want to divide it by 2 factorial. And then you will get a correct answer.
Mhm.
This one, it should be like this. So the student was saying that in order for 2 vowels to be like never next to each other, the setup for vowel and consonant. So first, we will decide order for vowels and consonants. It has to be like this. This is the only way that you can set up vowel and consonant such that no 2 vowels are next to each other. If you switch anything, the 2 vowels will be together. Because in order to separate 4 of them, you need something in between all the time. And luckily we have 3 consonants here. And then step 2 is a student decide to count how many ways are there to arrange the consonants. You have N, T, and R. There are 3 distinct objects. So you have 3 factorial ways to arrange them. And step 3, the number of ways to arrange the vowels. Here you have 4 vowels. However, 2 of them are the same. So you have to take the total number of vowels divided by the number of vowels for each type. Type O, you have 2 objects. Type A, you have 1 object. And type I, you have 1 object. So they just 4 factorial divided by 2 factorial. And then in the end, you just multiply everything together. And this should be the final answer. Is there any question about this one? How about part 2? We want all vowels to be in alphabetical order. However, they can be next to each other or they can be like separate. I got 60. How do you get it?
I did a similar thing. This time I arranged the vowels first. So I had A, I, O, O. Then in those we have 5 spaces, right?
Mhm.
And then so I said, okay, for A, I, O, O, we only have 1 combination because we want it to be alphabetical, right? We don't have 4 different combinations, we just have 1. Then I said we have 5 spaces, so let's choose 3. So it's 5 times 4 times 3, which is 20 times 3, which is 60.
Wait, so you have 5? 5 for what?
5 times 4 times 3. I said 5, choose 3 because we have 3 consonants.
What does 5 stand for? Like the number of ways
Oh, yeah, number of ways to put in the blank spaces to consonants.
in the blank space. Okay, let's say you choose this one to put in the consonant, right? Let's say somehow I put in N here, and then what do you times 4?
Oh, wait, you could put them all there, couldn't you? Oh, yeah. Yeah, I don't think I thought of that. Never mind.
Yeah, but it is pretty close. So the student was saying that for the vowels to be in alphabetical order, there is only one way to arrange them. They have to be A, I, O, and O. That is the only way for them to be in alphabetical order. And now we will try to see where can we put the consonants in. So if we look at AIOO, there are 5 possible places that we can put some consonants in, right? So I first put the first consonant. There are 5 options for me. I can put the first consonant here, or put it here, here, or here. And then once I put the first consonant in, let's say I put it in the first position here, I will have to find the position for the second consonant. Where can I put the second consonant? You will see that now we have 1, 2, 3, 4, 5, 6. 6 possible places to put the second consonant in. So we have 6 ways. And let's say after we put the second consonant in, let's say I put it here, for example, I will put the third consonant in, which is also the last one. I will see how many possible positions I can put the third one in. Now I will have 1, 2, 3, 4, 5, 6, 7. After I put the third consonant in, I finish like my process to arrange every letters. So I can multiply them together. And you should get, let's see, 5 times 6 times 7. Does this make sense for everyone?
Doesn't that change depending on where the second consonant goes, or am I not understanding something?
The thing is, no matter where you put the second consonant in, it will give you 7 possible places to put the third consonant in, right?
Oh, okay.
Does that make sense or no? Actually, I think I missed something here. The thing I miss is that decide
Oh yeah, I see.
first, second, and third consonant. Yeah. So I would have 3 factorial ways to do that. And if I multiply, I should get this number. Let me know if something doesn't make sense. I might make mistake.
I think your screen is frozen.
Can you see it now?
Yeah.
Yeah. I see the question. Why is it 5 times 6 times 7? Okay, so let's start from the beginning. So first, I have to make sure that all the vowels are in the order AIOO, right? And then after that, I will decide the position to put the first consonant in. And how many position is that? I can put it in any like blank space that I have. I can put it here or here or here or here or here. So I have 5 possible places to put the first consonant in, right? And after I put the first consonant in, let's say I put the first consonant in here, I will have to insert the second consonant. And how many possible places I can insert the second consonant? I can input it here or here or here or here or here or here, which give me 6 possible places, right? And we have to realize that it's not because I insert consonant 1 in this position, but even if I input consonant 1 in this position, it will still give me 6 possible positions for the second consonant. Does this part make sense? Let me know if it does not. Yeah. And then after I input the second consonant, let's say I input the second consonant here, I will have to finally input the third consonant, right? The third consonant can be in here, in here, in here, in here, in here, in here, or in here. So I will have 7 positions that I can put the third consonant.
Even if you put them like in the middle, right, it'll still open up like 2 new
Yeah, exactly. Yeah, that is correct. And just one thing, I think I kind of did it wrong here. That is, I shouldn't need the last one. Yeah, now I think about it, I shouldn't need the last one. It will overcount. The thing is, because when I put the consonant in this kind of order, it already take into account, like, let's say my first consonant is N, my second consonant is T, my last consonant is R. When I insert it in different position like this, it already take into account, like, okay, N might be before T and T might be before R. Or if I put N in this position and T in this position and R in this position, like it already takes into account the order of R, T, and N in the word itself. So I don't need to decide what is the first or second or the third consonant to be input. So this should be the final answer. Any question about this one? How did you get 4 factorial divided by 2 factorial again? Yes, it was because for question 1, in the step that I arranged the vowels. What are my vowels? My vowels are A, I, O, and O, right? So if they are these things, then I have 4 factorial, but you have 2 similar objects, so you have to divide it by 2 factorial. If you have 3 similar objects, you divide it by 3 factorial. And if you somehow get like A, I, and O, then you have to do 5 factorial divided by 2 factorial and 2 factorial. Does this make sense? Yeah. Okay, so if there is no question, it is the end of our tutorial. I crossed out 4, so the only question we didn't go over is question 3. I will try to go over this question for TUT0102. And if I cannot, then I will make separate video for that question because it's a pretty important one. Is there any other question? Okay, if not, then I will end the tutorial here and I will see you next week. Good luck with your midterm.